We manufacture life-saving equipment. We build products that must work the first time, every time. And our quality policy is we build quality products knowing they are used to save lives. That quality policy is something that we use to make every decision, and we use in the design, the development, the manufacturing process. It really is in the fabric of this entire company, and every employee knows that quality policy by heart and understands how it applies to what they do. We have brought in the most talented engineers that we can, and we've invested in SolidWorks CAD systems and state-of-the-art design and evaluation, simulation software programs and equipment to be able to really design the most reliable products. From a mechanical point of view, we take these three-dimensional drawings, we output them as SLA or SLS prototypes, which are created out of a urethane bath based on a computer drawing without ever having to cut any steel. In 24 hours, I can take a drawing and hand it to an electrical engineer and have him put a prototype board and a prototype GPS receiver in that plastic case, and he can start testing and designing and evaluating the electronics much earlier in the development process than we ever could before. One of the things that a simulator lets us do is you can go back in time at any place on Earth and recreate the exact constellation that is visible to that point on Earth with a simulator, and you can go forward in time and do the same thing. If we wanted to simulate a heavy tree canopy overhead with maybe only 3 or 4 satellites visible on the horizon to the EPIRB or the PLB in that particular scenario, in a simulator I can create that situation. And then, let's say you want to bring in a rainstorm or a snowstorm, we can simulate that too by bringing the signal level down and further attenuating the signal to make it more difficult for the receiver to work. We can test it, bring the beacon out, modify it, bring it back, and reproduce that exact scenario to see if we're making progress. No electronics manufacturer could really claim to be as obsessive about quality as ACR is if it didn't have an extensive test facility, and we've got a great test facility. We can test for shock, we can test for impact resistance, zero atmosphere, vibration, a broad range of temperatures, ultraviolet degradation from the sun, humidity degradation. We can test for salt, exposure to salt fog and the corrosive elements in the marine environment, and all sorts of environmental tests. But what we're really trying to do is make the beacon fail, make the gaskets fail, make the switches fail, make them transmit out of frequency, so we can figure out how to make them better so they won't fail when you need them in real life. The first step in the manufacturing process really begins in incoming receiving. It's in this particular station where we verify that the parts we receive from our vendors are in fact exactly what they're supposed to be. If we can't give perfect parts to the production floor, they can't build beacons that are going to work the first time, every time. In order to equip our incoming inspection team with the latest in technology, we have invested in equipment that allows them to check tolerances electronically with our Smart Scope, for example, or with the XMET X-ray analyzer. We're able to determine the exact material content of components. We've invested in this technology so that we can build products that we know are going to work when they're required to. By investing in the latest in technology relative to surface mount technology, that allows us to keep the production here in the U.S. and maintain control of the manufacturing process. And process control is the key to quality control and quality assurance. In the SMT room, we place the paste solder on the boards with a stainless steel screen that gets vacuumed down to the PCBs, and then we go to a quality assurance step, and we have an optical scanner that looks at the paste and makes sure that it's the right volume, the right placement, the right size. And then we run them through an oven that allows us to use a lead-free solder. We don't have to invest in lead-free, but that's something that we just feel it's the right thing to do. Once again, as we come out of the SMT machine, We go into an optical inspection station that checks the part, the soldered part, against a blueprint, makes sure that all the right components are on the board, on every board, and that they're in the right place. And then there's some of the components that are extremely small, or the solder points, the ball grid array is on the back side of the, or buried in a way so that we can't visually inspect it. From ACR's point of view, we have to be able to ensure that those solder points are all perfect. So we have a PCB X-ray analyzer. You could say we X-ray our solder balls because we have to. We can look through the part to the solder point on the backside and ensure that it's going to really basically continue to work, not just the day it's manufactured, but over a lifetime of drops, over a lifetime of vibration and temperature changes and thermal shock. The boards have been tested, tuned, and approved by quality, and the next step is we conformally coat them in a layer of silicone, which basically we spray this thing with silicone and we cure it in an oven. The value of conformal coating is that it allows us to protect the board from electrostatic discharge. If for some reason the case should ever be compromised, it protects the boards from water intrusion and gives it a better chance of working in a crisis mode. And it also gives us the opportunity to inspect that. It preserves the board if it ever comes back to us. It allows us to inspect the board and make these products better over time. No one makes us conformally coat these boards. It's not a government mandate. It's something we do because we believe it's the right thing to do. Here we are at the final phase of assembly. And we take the fully assembled and sealed board, and before we put it into the case, we run it through a 45-minute, fully operational burn-in test. It's kind of like a test drive. We power this board up, we hook it up to an antenna load, and we run it just like it would in real life. Once that beacon has passed that final burn-in test, we assemble it into the final case. We do some other mechanical tests, we do some operational tests, and it goes out to be packed. But the final stage, really, the queen moment of the entire process, happens in this final assembly room. There's one more step in the process. Essentially, the process is over and we've shipped the product and it's gone out the door. But it really isn't over yet. There's one more phase in this science of survival, and that is pulling random samples from production lots, taking them back to the test lab and testing them against their original standards to make sure that every unit that we're building in production is as good as, and most generally it's better than, the units that we sent to the test lab way back in the beginning of the design and the evaluation process. No one tells us that we have to do that. No one makes us do that. We do it because it's the right thing to do. We do it because we build quality products knowing they are used to save lives.